What is up, you guys? My name is Manak and welcome back to my YouTube channel Get Certified. I'm your host to get your next ABAP certification. So let's jump right into it. In the last video, we talked about variables. In this, we are going to talk about the keyword static. So before we start, don't forget to hit my subscribe channel. Don't forget to subscribe my channel rather. Hit the like button and don't forget to share with your friends who are interested in having the getting the ABAP certification. So in this tutorial we are going to talk about the keyword static. So the static keyword is basically used to declare the data with static validity within the procedure. Variable declared within the with data statement exists as long as the context in which they are defined. Now variables are defined in the ABAP main program exist until the runtime of the program, and the local variable defined in the procedure only available inside the procedure um, as the procedure is running. So you can declare a variable using the static keyword to return a local variable beyond the runtime of the procedure as opposed to the variable. The declared variable within the procedure will exist for the lifetime of the main program and is available within the procedure. Hence, if you want to keep the value of the local data object beyond the runtime of the subroutine, then you should use a static keyword to declare the variable. Let's talk about a little bit. Let's uh, Let me show you an example actually, so it'll help you to understand better. So let us comment the previous code that we did, and let's uh, let's write a code for our static. So let's do it this way. Let's use do 5 times, and let's end send over the statement. Right. So what we are going to do is let's perform. Let's make a perform. Let's make a perform a data object. There you go. Let's perform data object example. Perfect. Here let's declare our form, which is data object example. Okay, and let's use the keyword and form just to make sure we tag. Okay, let's use a data statement. So let's use data. Let's use count count 1. Let's declare it type integer. There you go. Let's use statics. There you go. Oh, statics. There you go. The keyword statics, and let's use another variable count 2. Let's also declare it of the type integer. Let's do a small operation, that is count equal to count 1. Let's do +1 and for I'm sorry, this is your count 1, and let's do it count 2. Let's do it count 2 +1. You should be able to see the difference between static and when we declare it as a normal data object, and how if you declare it as a static data object. So let's display this value. So let's use the write statement. Let's use an inline. Let's use next line keyword, and let's do it count 1. So this let's do it this way. Let's for the static part of it, and let's use our count count 1 variable, and let's use our count 2. let's see what count do for this should be the count 2. Let's use it for displaying count 2. There you go. Looks like okay to me, but why is there an error? Let's have a closer look. Alright, so that's inform. Alright, let's check what's the error. I'm sure there's an error. Count 1 is not defined. Okay, sorry. So basically it should be a comma, which is the concatenate I used to indentation. I'm so sorry. Right, there you go. So let's use the check. Let's activate. So you should there you go. So basically you see the count 1 value which we declared inside our form has the value which is 1, but our but our count 2, which is declared with the statics keyword, retains the value for the runtime of the program, and the count 1 value, if you would say, does not retain because it is declared using the data keyword. So I hope you are able to see the difference between count 1, count 2, the way it was declared. So the variable count 1 is initialized again when the subroutine is called at the next time, whereas the variable count 2 is initialized only during the first call and keeps incrementing the value using the subsequent call. So there you go. Let's talk about another keyword, which is class data. So basically, a class data keyword is used to declare a static attribute for the class and is valued for all of the instances of the class within that program. And then let's talk about the parameters. Parameters keyword is used to declare an elementary data object that is also displayed as an input field on the selection screen. And let's talk about the select options. So select options keyword is used to declare an internal table that is also displayed as an input field on the selection screen. So let's see other ways we can declare variables with the use of the data keyword. So let's use data. So let's use data. Let's use a variable 1, and let's use the type as integer, which we already saw. So data, let's see, variable 2, type variable 1, which is completely legal. Let's see the third type as data. Well, this should be without space, mind you, otherwise it'll show you syntax error. So variable 3, type say a string. So type a string value, and you can force the value of the string as hello. So the variable name variable 1 can be up to 30 characters long. You can define the technical attributes of the data object during the declaration. You define the data type, length, and the number of decimal places, although for some types of length and number of decimal places are fixed. Say for example for the type D, decimal, for type T, etc., or come from the ABAP dictionary directly. So the variable is declared using the ABAP dictionary type. If you are using the type key keyword to declare the data, then the type could be predefined data type, an existing local data type within the program, or an ABAP dictionary data type. So if you're using the like keyword to declare the data object, the object must be an existing data object in the program that has already been declared. It can be a database table, view, structure, or also it can be a component of a table or a structure. Well, the value keyword is used to define a starting a value for the variable. So So for example, this you would have the value hello by default, and the like statement, for example, is allowed in an ABAP object only to declare local data object or system or sy fields such as sy uname, such as sy uname, or like system datum, or system use it, for example, for showing the current time. There are huge number of standard data fields. So there you go. So let's go on to the next topic, which is the ABAP data types. Did we talk about? No, we did not talk about data types, right? So the ABAP data types are basically the predefined data types which are provided by the ABAP runtime environment. The predefined data types can be used in all ABAP programs, and you use them to define basically local data types and data objects in your programs. The ABAP data types can be used to describe a single variable and elementary data object. They can be used to define the components of the structured data objects as well. Well, one way to classify the predefined elementary data objects is fixed length versus variable length. So there are a total of 13 preliminary data. Let me just confirm. So I think there are a total of 13 elementary predefined. So predefined data object in number. Yeah, so I think there are 13 predefined elementary data types. Right, so there are 11 fixed length predefined data types and 2 variable length data types. The first, let's jot it down. So the four character types, are either numerical. So N is would be your numerical text, C is your character text, D is your data type, and there's another called T, which is your time type. So fields of these types are known as character fields. Each position in this field is taken up space for the code of one character. With the adoption of Unicode, each character occupies 2 to 4 bytes. The three numeric types are integers and floating point numbers, which is denoted by F, and the back numbers, which are used to display and calculate numbers. Basically the number data types I, F, and B, they differ in the inner representation of value ranges, and the arithmetic calculations and the arithmetic used in the calculation. The integer type represents a whole number, so the value can range from anywhere between -2 to the power 32 to +2 to the power 32, and non-integer results of arithmetic operations are rounded and not truncated. So let's just to give you an example, let's have a quick code just to give you an example. Let's use data. Say number 1 is a type I, and let's have the value of 5, and then let's use num2 or num2 type of I, and let's use the value of 2, and let's divide them. So let's say results. Okay, so let's say data. I'm typing too fast because of regenerering and ending up making more errors than actually going faster. Okay, so the result is of type I, integer. So if you do result equals num1 divided by num2. So basically, if you output this, the result would be 3, and instead of so this is what I meant when I said arithmetic operations are rounded and not truncated. So we are going to continue with the ABAP data types in the next videos. So guys, thanks for watching my video, and don't forget to subscribe to my channel, and see you in the next one, guys.